Good afternoon, everyone. Thanks for coming. My name is Jimmy Bogard. You can find me on Twitter at @jbogard. My GitHub is github.com, also /jbogard. And you can find this presentation and pretty much anything else I do also on that GitHub. I blog quite a bit on jimmybogard.com, though I guess less than I used to. And for my day job, I actually work for a company called Headspring, which is a consulting company out of Austin, Texas, where we mainly build custom enterprise software. And this presentation is a story about two large projects I was involved with. I had the benefit of having two projects in nearly the identical domain set about 4 to 5 years apart, where we could take all of the lessons we learned from the first project and then apply them to the second project. So part one begins with our Majestic Monolith. This term, the Majestic Monolith, actually comes from the creator of Ruby on Rails, DHH. And when everything was really getting hot and heavy about microservices, he said, no, you don't need to do microservices. That's a bunch of garbage. Actually, what you should do is build these monoliths, but build them really, really well. And that's what we didn't start out to do, but wound up what we created with the first project, which was a true monolith. So I want to give a little bit about the project background because some of the domain is important to see how we slice things up a little bit later. So the project originally started with a project failure, actually. The original company that was trying to develop the software for the Texas Juvenile Justice Department spent a year building nothing but requirements documents, and that was it. So after 12 months of work, the only thing that had to show for it was like 1,000 pages of Word documents, most of which said, to be determined later. Like, it didn't have any actual requirements in there. It was just, a bunch of form letters. So absolutely no software to show for it. So they got canned. And we came in and said, we'll build it differently. We're going to build it using agile methodologies, of course. And this was going to be the very first agile project for any Texas government agency, which meant, of course, that we had to do it by the book. In fact, our contract with them was to get paid by the sprint, which, by the way, I would never recommend doing ever again. Do not get paid by the sprint. It was also the first domain-driven design project for any Texas government agency. A lot of the team members had experience building things in a domain-driven design flavor for a few years, but this is going to be a really big one we're going to build for the state of Texas. Now, the previous system, the way this worked was every single county in the state of Texas had their own IT budgets. And some counties were large because they had large cities in them. And so they were able to afford either a large complex system on their own or they could build one on their own. So basically all the big cities in the state of Texas had their own systems. But there's a lot of other people in the state of Texas that need something in order to manage. For us, it was when a kid gets in trouble and you needed to figure out what to do with them. That's what the system was supposed to be dealing with. So everyone else had, it was a Microsoft Access application, which of course, Microsoft Access is not that great, but it worked okay for them until they got bigger and then they needed something else. So they looked at this and said, you know what, none of these systems is that great. How about we pool our money together to build one system that everyone uses? And that was the idea behind the Juvenile Case Management System, or JCMS. All these different counties in the state of Texas, everyone would use this one single system, and then hopefully this system would be better than everyone's individual systems. So lofty goals. This is actually like lots of behind-the-scenes politicking to even, I don't know how the money actually worked here because everyone has their own budgets and taxes and stuff, so how do you pull all this money together? They figured it all out, pulled all the money together and said, let's build this one single system. Now, they had a number of project goals associated with this initial system. There were goals before we came on board. And some of these goals really set in stone some of the mistakes that we made early on, but we couldn't really do anything about it because it was literally like they printed the poster out and stuck it on the wall of these different goals. The first one, which was a lofty goal, which was to increase knowledge sharing. And they had like the most depressing stories about kids that got in trouble. So we actually had to be careful about later when we were doing test data because they have stories like a kid gets in trouble in Dallas. And Dallas is right next to another very large major metropolitan area known as Fort Worth. And if a kid gets in trouble in Dallas, they may send him to live with his uncle. But what they don't know is that he's gotten in more trouble at his uncle's house over in Fort Worth. And they don't know that because the systems don't talk to each other, and there's no way for someone in Dallas allow us to look up that information over in Fort Worth. So they had some like real personal goals to say, we want to make sure that we are able to share more knowledge about what's going on with these kids to better serve them and hopefully have them lead better lives. The other thing they wanted to do was to create a system that covered every single aspect of the legal process of a juvenile, like every single thing from when they got into trouble to hopefully they're out of the system at the end. Have this one system do absolutely everything, and that meant that it touched like 2 or 3 dozen state agencies in this one single system. This would provide a complete picture of the entire process of the legal system for a juvenile. And it was a complex process. In fact, they had this poster on the wall. Very large picture. This is the legal process for adults and children, or juveniles. And you kind of go down these winding paths. One of the things I liked about this is it looks like it assumes there's actually 3 times as much crime that exists than is reported, which I don't know where they got the statistics, but there it is. And then it's supposed to wind down, and eventually there's some kind of result at the end where they're out of the system, or they're released, or something happens with them. So our system was supposed to deal with every single aspect here. And as we started the project, the very first thing we need to do was figure out who was going to be using the system. And at that time, there was a really popular way of doing this of user role mapping. So we'd assign like names and roles to different kinds of personas in the system and start to name them and say, oh, well, that's going to be this person doing this or that person doing that, to think of our head some real person. But we wound up with like 72 different kinds of people that are using the system. And that's something that should have hinted at us that perhaps the system was too big when you have 72 different kinds of people using the one single system. So if everyone from Pete, the probation officer, to Lucy, the LEA approver, I still don't know what that means, Fred, the fee clerk, and Judy Judge, of course. Well, this was too many. These are all on giant Post-it notes that we stuck on the wall, and we couldn't make heads or tails of it, so we started to have to color code them. So we started to group them into different agencies and groups to be able to figure out like these kind of people belong together, and those kind of people belong together as well. So that was one of our very first big lessons, was that the chapter that no one ever reads at the end of the DDD book about strategic design and bounded contexts, well, those are a thing that you should actually consider designing into your systems and not just dump everyone in the same giant system bucket. Over here on the right, I've got a drop down of looking at a single juvenile, and each one of those menu items is another agency that deals with just that one thing. So going from 72 different personas leads to these like gigantic menus where you could just do absolutely everything related to that juvenile. One of the other problems we ran into was we didn't have each of these different agencies represented with domain experts. We actually only had one of them, and that was the probation department. They were the ones that really dealt with when a kid gets in trouble to make sure that they got in the right path. But everyone else is just kind of still an important part of the process, but we didn't have them involved whatsoever in our conversations. And part of the problem was it's just like physically impossible to have all these different product owners to be able to give feedback on the system. There's just too many things going on. So when we have all these different agencies, all these different people involved in the modeling of the system, it meant that no one could agree on what something meant. And so that led to ambiguous modeling. We had something called a person in our system. There was a person table, a person object, a person repository, person controller, person service that dealt with person. Now, what does that mean in the domain of juvenile justice? Nothing. It meant absolutely nothing. But because we were trying to have this shared data that, a person that needs to only exist in the system only once means I have to eventually have this like kind of God table that contains every single piece of information about a physical person. So that meant nothing to anybody. And that should have been an indicator to us that if we want to build a ubiquitous language, it actually should be ubiquitous. Like people should actually use this term on a daily basis. But no one used that term, but it was one of the most central concepts to our system. We also ran into competing priorities. It turns out that government agencies actually don't like each other very much. They have a lot of competing priorities, competing budgets, and they generally don't like to deal with each other, but we stuck them all in the same system. So when we asked each of these different agencies, like, what's the most important thing you do with your job? The law enforcement agencies would say, well, someone does something wrong, so we arrest them for it. That's like all we do all day long. Okay, that's great. The courts, what do they do all day long? They conduct trials. That's all they do. So the trial is the most important thing to them. The prosecution department says cases are the most important thing that we have to deal with. And finally, our actual product owner said juveniles because it's all about the kids, right? Make sure those kids get the help they need. So looking at this, like you can't build a single system that satisfies all these radically different needs, which we saw. The juvenile probation department at the end, they love the system because it was really built for them, but no one else, turns out, actually liked it. So that was our third lesson, that if you're going to build something that has a core domain, everyone should agree that's using the system what that core domain is. So you shouldn't have these radically different ideas about what the core point or domain of the system is. You can't build a system that supports all those different domains all at once. Sometimes, though, we actually did get some agreement on a single term. But it turns out that those terms even meant something different for all those different people. So something like an offense, which is something something that's illegal that you do, that's called an offense. When we asked all these different groups, like, what does offense mean to you? What does that term mean? Well, the law enforcement folks, for them, it's just a form they fill out. When you do something wrong, we fill out this form, and that is the definition of what that thing is. It's this form. The courts say, no. It's not the form. It's something we bring to trial and adjudicate. Prosecution says, no, that's not what it's for. It's something we need to charge these criminals for. And they really hate these criminals, so they're really excited when they get to charge them for things. And then finally, the juvenile probation department is like, no. Offenses are something we want to get past because we want kids to be moving on to good and better things. So for them, even this core model, this term that everyone used, no one agreed about what it actually meant in the system. So that was our fourth big lesson, that if you have ubiquitous language and you can even agree on a term, a word, then it should mean the same thing to everyone in the system. And if it doesn't mean the same thing to everyone in the system, then your system is just too big. Now, the final lesson was, I think, mostly my fault. So I can point to all these other ones and say, you know what, all those came from us signing up to build a system that tried to satisfy all these different folks. But if we had approached these different state agencies and said, you know what, maybe you should have more than one system, we would have never been awarded the contract, and we would never have been able to build that system in the first place. So I could say, the first ones was just bad assumptions on the people that really came up with the idea. The next one, though, was definitely my fault, which was early on in domain-driven design, everyone was really excited about all the different domain-driven design patterns, which were entities and aggregates and value objects and repositories. We argued a lot about what those terms meant, how to implement them, and how the code should actually behave. And so we got super pattern happy. This is something that I wrote many years ago. This is a repository for that one of the God objects, which is an offense. At the time, there were two competing patterns for repositories. One was a generic repository, which meant you had kind of just a facade over your ORM underneath the covers. Or you had a specific repository that says, I'm a repository for this kind of domain object. I did both here. I did both the generic and the specific repository. And you can see like all these different methods that we have on here are the different kinds of queries we'd have in the system. We also had a very hard rule that we shouldn't directly depend on the ORM because, like, just in case we switch it out. Has anyone actually ever done that? Like, switched out an ORM? I have, actually, several times, and this pattern makes it impossible to do so. Because if I want to change the implementation of one of these methods, it actually affects everything else in this application. I also don't know, like, for one specific method, like, who is using this and why? If I change one of these methods, am I going to break anybody else? I have to break out into more methods now? So us, over time, just kept adding on more and more to these central patterns of repositories and entities and aggregates until they got just so large they were completely unmaintainable. Now, Eric Evans, the writer of the DDD book, I blame it on him because those were the first chapters and they were the most exciting ones. So if he wanted us to read the important chapters, he should have put those first. And he actually said that. He had a presentation with something like DDD 10 years later. And in it, he says that if he had to write the book over again, he would take the part that's about bounded context and stick that at the beginning of the book. And the part about entities and aggregates and repositories, he would either stick them in an appendix or just remove them altogether. And so that was our fifth big lesson, was that the structural patterns described in the domain-driven design book are actually the very least important part of domain-driven design. But us as developers, we like arguing about stupid stuff, like this entity looks better than that entity. And so it's fun to kind of argue about, what is a better entity or aggregate design than others. So we focused a lot about these different patterns, but none of those patterns actually added really any value to the end client. So this turned out to be quite the large system. If we look at the final tally of this application, this is an MVC application. It had 195 controllers, 652 actions, 121 roles. We started with 72, and it grew over time to 120 different roles, 218 entities, 184 value objects, 352 enumerations, but we had around 50 counties deployed by the time we left the project. So although it was a very, very large system, too large, we still deployed it, and it's still under active development today. So it's big and unwieldy, but it's still a success in that we actually shipped and continue to ship the project. So the original picture we were shown of the Majestic Monolith, of this happy fun place where everyone rides flying cars or something, and everything's clean and whatever. This is this very utopian view of this picture. But that's not what we found in reality. It's more like District 9, where it's everything's ramshackle, put together, duct tape, baling wire, and just kind of strapped together, and everything's just kind of holding on for dear life. So I was on that project. By the way, that's the project that AutoMapper came out of, so you can kind of blame that project for that as well if you want to. So we finished that project, we shipped it, we handed it over to the clients, and kind of went on our way. A couple years later, we were approached to build the adult system. So if you remember that picture that had all the different arrows and lines that were going through it, the juvenile part was actually just that slice at the bottom. There's a whole top section which was the adult path, and we were approached to build that adult one. Well, we saw how much bigger physically that was than the one below it, and we said, well, that's going to be a lot more money to build that, and we don't think we can do it. So we didn't get the bid. Someone else got it. And about a year and a half later, it turns out that system was way too big and they failed. And so we got to be involved in part 2, which was our do-over. The do-over was trying to take just one aspect of that original approach and trying to deploy that. And the reason why we were able to do that was they ran out of money. So them trying to build the entire adult system, once that didn't work, with the money left over, they said, well, we can just build one single part of this overall application, which was actually a much better end result. So it was going to be too expensive, costly, risky to try to build the existing single system. Even though they did try, it did fail. And instead, what we'll do is focus on one single agency at a time. Because we looked at the different governmental agencies, those are the most truest manifestation of Conway's Law, that the government has enforced these communication boundaries and these budgets and things like that. And so we'll focus on just one agency at a time, and we'll start with the prosecution department. We should have known, looking at the original picture, it's color-coded for us. Why don't we just look at the colors and say, let's build systems based on the colors? No. One system for the entire thing, and we saw that turned out. But this time around, we're only going to focus on one single government agency, and this time it was going to go a lot better. Because this time, we were actually going to pay attention to those lessons we learned and say, this time, we're actually going to build around bonded context. So we'll draw this little line around the prosecution department, and inside that box, we'll have things that only make sense to the prosecutors. They don't make sense to the outside world. We will have other systems and services we need to communicate with, but we'll have some kind of anti-corruption layer between our system and them to be able to translate between what their words mean and what our words mean. So inside this box, we have lots of things that make a lot of sense for prosecutors, but don't really make sense to me. Like dockets, I still don't know what that is. It's like papers on a floor or something. I don't even know. Grand jury is a thing in the States about bringing cases to trial. So yeah, we have all these things that just make sense for that individual domain. So as part of this, we always go out to talk to the end users to say, I would like to learn a bit about your domain and what you do on a daily basis. And we were excited because we had built that original juvenile system that these new people would also have used. So a prosecutor in Dallas, for example, would prosecute both juvenile cases and adult cases. So we're like, oh, great, I finally get to meet the users of this system. Won't they be excited? Won't we be excited? That could not be further from the case. Because when we first met our first prosecutor and we introduced ourselves, it's like, hey, we're the developers of the juvenile system. Literal quote. Not something you want to hear about a system you built. He didn't use the word poo emoji either, by the way. He was a little bit more vulgar when he was talking about it. And it's like, that's shocking. I thought everyone loved this system, but it turns out the people that love this system were the people that we designed it for, and the people that we didn't design it for and just kind of glued on to the side, of course they don't like the system because it's not built for them. It's not tailored to their domain, tailored to their daily business. So in original conversations with the prosecutors, we asked them, like, what's the most important thing you do? They said, we prosecute cases. Cases are the most important thing. If you look at my desk, it's a stack of cases. That's what I deal with. So while the previous system was all about the kids, the prosecution system was all about cases. So in this one, it looks like I got into some trouble. I burgled a rail car. That's the one I like to use the most. And whenever the user is using the system, the prosecutors, it's all about how the case is progressing. It has nothing to do with like the defendants. When we first started the system, we actually looked at making it people-centric, like we made the previous one. We said, well, it's all about prosecuting defendants. So let's make the defendant the most important thing. And after about 3 months, the prosecutor's like, no, it's not the defendants. It's not at all. We couldn't figure out what it was, but finally we settled on case, and they're like, oh, of course it's case. Why are we paying you all this money when it's such the obvious thing that like cases are the most important thing? But what that allowed us to do is, by settling on something that was very specific to the domain, we were able to build experiences that were centered around how they worked. So this one is a very task-oriented system, as opposed to the previous one, which was very kind of data-oriented, CRUD-oriented. So that was our first lesson in this new system, that by having a cohesive system and a cohesive domain, that brought us greater clarity into how they worked, deeper insight, and allowed us to build a much better system in the end. One of our other major mistakes with the previous system was around modeling. And a good example was around modeling security. The previous system that we had, roles were hard-coded into the system. So that like Judy Judge and Larry the law enforcement officer, those are actually the roles in the system that define security. But we had a large gap between different counties and how they use the system. So you had a very large county like Houston's or Dallas, which has millions of people there. They're going to have very complex roles in security because there's a lot of people working for those agencies. But if you look like Podunk, West Texas, that has a population of like 20, then they don't need all that complexity. So when we looked at this and we said, instead of us building things that are hard-coded in there, why don't we allow things to be flexible where they need to be and be inflexible where they shouldn't be? And a good example are the permissions. Initially, they wanted us to have dynamic permissions because they said, well, we might have new users come on, they can do new things. But for us, permissions are always tied to a specific action the user could perform. So we built granular task-based permissions into the security of our system. So the permissions associated with different actions were named after that different action. So things like editing a case, assigning a case, those were two different things different users can do. So we had different permissions associated with each of those actions. That also allowed us to directly assign permissions to the actions inside our application. So there was a one-to-one mapping between like controller actions and then permissions associated with those different actions. So when I wanted to define a permission, I had one place I could go to that said, this is where the permission is defined and enforced for everything in our system. So that was our second big lesson. There's always going to be desire from the client to make the system as flexible as possible. But if we make things as flexible as possible, it forces us to do a ton of configuration to be able to configure the system to run. So there's always going to be a balance between making it flexible and making it rigid. And what we really paid attention to in this iteration was making sure that by talking to all the different counties, we cataloged the differences between those different counties and then looked at what was the same between all those different places and made sure that they were flexible where they were different and rigid where they shouldn't be. As part of one of our visits to the individual counties, we talked through the kind of problems they were facing on their job. One of the things we wanted to do was make sure the system we were building actually helped do their job better. And so we were really excited when we talked to two counties, Fort Worth and Dallas, which are like 50 kilometers apart, said, okay, what's the main problem you deal with on a daily basis with your existing system? And they both said the same thing, file management. We're like, oh, great. You know, we two birds with one stone. If we solve this problem once, we solve it for both of these counties. Now, it turns out the underneath the covers file management problem was vastly different. In Fort Worth County, they had a lot of money associated with their IT department. So their CIO there had a lot of influence. And so their file management problem was that they had too many files, too many digital files. So all the kind of CCTV cameras and things like that becomes evidence. You have to store that somewhere. And there's certain requirements about how long you have to store it. So they had like petabytes and petabytes of images and videos and all sorts of digital evidence that they were just having a problem just storing. Like they're physically running out of space to be able to store all these bytes of information. It's like, oh, that's interesting. That's a fun problem to solve that I think we can help you with. We go to Dallas County and said, yes, we also have a file management problem. All right, show me. It's up there. The ceiling is dripping water onto my paper files because they are still a paper-based system. Like they were so backwards or so behind the digital times that they had stacks and stacks of boxes of paper files everywhere you walked. A few years ago, there was a big hurricane that went through Houston. And one of the things that happened was that it ruined and destroyed reams and reams of files of all these paper-based workflows that people were working from because they wanted to store those files where no one cared about, which was in the basement. Well, when the basement floods, that's like years and years of files destroyed. So that was their main problem. They didn't want to store files in the basement because of what happened with the flooding. So they were just physically everywhere. I would have to like turn sideways sometimes to walk through the hallways because there are just boxes and boxes of physical paper files everywhere. So while you had one organization that had digitized everything but could no longer maintain that system, we had another organization that was 100% file-based, and we were trying to build a prosecution system that could solve both of these kinds of problems. So that came into the flexibility discussion, was looking at these two organizations and saying, well, we don't want to build a 100% generic system they can do anything with because that'll take forever to configure. So we have to have some flexibility into how you can define your work. And so we wound up building flexible workflows. And the general idea here was that every single county will work slightly different. Instead of us coming there and telling them, this is your workflow, this is how you need to work, what we can do instead is saying, we'll have a system that allows you to dynamically define how cases work their way through your system, because it turns out the legal process is defined in terms of like the entrance criteria and the exit criteria, but once a case is inside your department, there is no recommendations, no documentations. Just do whatever you want to get the case prosecuted, but you figure out how you want to do it. And so every agency they figured out their way of working. So he said, we're not going to bring in a workflow engine. Those are too big and expensive. We'll start with the simplest thing that could possibly work, which is just basically a state machine. We have statuses or states and transitions, and each of those has different names. And we started with the simplest thing that could possibly work. Instead of us looking way too far ahead to say, let's build some super complex workflow engine, we said, let's just build for what we know that's right in front of us, the stories that are imminently ready to be developed, and design the workflows just for that. So initially, this picture just started out with a status and a transition. I had different states a case can be in, and then I have transitions between those different states. At some points, we ran into the issue that only certain users and roles could be able to perform certain transitions. So like only certain people could shred or like destroy a case or just get rid of it altogether. And some people couldn't. And so we added on top of that security that says only certain roles can perform certain transitions. Sometimes we'd had different counties that wanted to have specific actions associated with those transitions. And so we said, well, if you want to customize what happens as part of transitioning something, like show a custom screen or widget or UI, whatever, and then what we'll do is we'll model that specifically as a set of actions associated with those transitions. This picture started out very simple, and we evolved it over time to be exactly what was needed for our customer. I wouldn't have predicted that we ended up with this model at the end, but by evolving it slowly at the time, we were able to build exactly the model and the behavior that they needed. This also allowed us to drive their work via queues, work queues. And when we physically went to their desks and looked at how they worked in physical queues. The paper-based organization had different boxes with different labels that said different kinds of cases. So these are like the high-profile cases. Dallas always had the Dallas Cowboys getting arrested for different things. So there was like literally a file. I'm not joking, by the way. There was like a box for athletes, pro athletes in Dallas. that had special things associated with them. And so we built our system so that we can have different work queues defined for different agencies. So we didn't even say how you need to progress things through the system. You could define these custom queues to be able to have your cases processed however you need it to be. And that was our third lesson, was that sometimes the model also needs a model on top of it. So we had our basic cases in the system as entities and aggregates and things like that, but we also needed something on top of it to manage how those cases needed to flow through the system. And while we could have started something simple, like just having a enumeration on the case object, we found that we actually needed to model how their work was being done and put a model on top of what we were seeing going on so that we could effectively move the cases through the system. Now, one of the other things that I looked at was the complexity of all those domain-driven design patterns, the structural patterns that we saw in the original system. I looked at all the giant repositories with hundreds and hundreds of lines of methods, and those giant God aggregates that are doing everything. And I said, you know what? This time we're going to throw out the sacred cow. Maybe that's not a term. We're going to ditch all of those patterns. And we actually went through a defactoring exercise where we got rid of all those different structural patterns and said, we're just going to hard code everything inside of the controller. And then once we took a step back, we said, okay, what are the commonalities between all these different things that are going on? Let's let the code itself inform me what the patterns are. And so what came out of that was modeling our system off of gets and posts, or commands and queries. Instead of us defining all these cross-cutting layers of services and repositories that were used across every single method, instead we modeled each individual action on its own. And so we'd have things like a well-defined query that said, this is the query for this one specific page. If I want to see how that query is handled for that page, I go to one single place to be able to do it. So here's an example of our system that's just showing a list of some things here. Cases, I guess. And this view model that's going to be shown on the screen is only defined and designed for that one specific view. This query is only going to be used on that one specific page. So if I want to change this code or change this application, I can go to just one place and know that if I change this code, I don't affect anyone else in the system. And that's very powerful. If I have the confidence to know that I can make any change here I want and not affect anything else, that means I can very easily and safely modify features and add new features to the system. And in fact, our developers were mainly only ever adding code to the system. They very rarely changed the existing code. It was typically adding on new pages, new screens, new buttons, new things the user could do. And so for us, we would say, okay, you have a new screen we need, so that's a new view model, a new query handler to be able to handle that query, and it's just adding new files and new classes to the system. As part of this, we also ditched any kind of abstraction or encapsulation layer over any of our dependencies. So you notice here, in this case, we're using inhibernate and structure map, so that's an ORM and a DI container. We said, let's just use those things directly. Just effing hard code it. Just use those things as they are and not put any kind of abstraction or encapsulation layer over those different dependencies. Early on, when we were doing the initial projects, we felt the pain of having all these abstractions, especially when we needed to do something very specific to that ORM, like have some kind of performant query. But we always had to hide it behind a repository in order to do so. So with this, we said, that repository is not really adding any value for us, so forget it. Let's just ditch it. And if we see that we're running into pain, adding or modifying code, then we'll go ahead and add it back in. But years later, after developing the system, we still hadn't encountered any pain with those patterns, so we've just left them off. Said, unless the code tells me that I need these patterns, we're just going to use these dependencies directly and just call right into those dependencies. So what this allowed us to do was to use the full features of any dependency that we were taking advantage of. So these ORMs are very powerful. They can do a lot of different things. But if I hide them behind some kind of abstraction, I can't take advantage of those features. So we said, let's not do that. Let's use those objects directly, use those dependencies directly so we can take advantage of the full feature set that those different dependencies give to us. Now, one of the things we looked at was, well, what happens if I need to change one of these things? That is, what if I want to switch ORMs for whatever reason? Want the repository help with that because it's encapsulating that for us and we're not depending directly on that repository or the ORM itself. Well, it turns out that was a faulty assumption. With this approach, by having every single individual query or command in its own handling class, that means that if I want to migrate from one tool set to another, I can do it incrementally. So if I want to, for example, this is using in Hibernate, which I don't think anyone really uses anymore, to switch to Entity Framework or Dapper or anything else, I can do that one single place at a time. I can go in here, switch this out to using something else, make sure the test passes, make sure that the application is running, check that in, and I've now migrated one handler. If I want to migrate from one overall dependency to something else, I now have an ability to do it one single place at a time. Now, I've actually done this now. We had one client where they moved from Entity Framework in Hibernate to Petapoco, and then we moved back to Entity Framework at the very end. And that was only possible if I could do that in an incremental fashion. That is, migrate one single use case at a time, make sure it was working, and then go on from there. In the original system that was using that giant repository class, it's like, how would you switch that over exactly? Would you switch one repository method at a time? What about something like repository.save? I can't just switch that over from one implementation to the other. Do we have two implementations of the repository? One is for one data access strategy, one's for another. How would I switch that out at runtime and say, well, now this path is working over here, that one's working over there? So using these patterns that stretch across the entire layer of my application, if we want to change those or swap them out, well, that means that I'll have to have this gigantic refactoring effort with one gigantic merge that comes in there at the very end. So that was our fourth lesson that we had with this new system, that we shouldn't just blindly follow pattern advice, but CQRS is really great. You should do that all the time. All these structural patterns of aggregates and entities, people love to argue about them, but ultimately we want to make sure that we were building the system that was needed for our customer. Not everything is going to have a uniform complexity in our system, so it doesn't make sense to use these patterns that assume complexity throughout the entire system. So we'd have some actions controllers that the logic was dead simple, which is just do the stupidest thing possible. Don't worry about entities, aggregates, any of that stuff. Just whatever the stupidest thing that could possibly work, just do it right there. And we let the code tell us through code smells to say, this is starting to look a little gnarly or starting to look a little ugly or exhibiting these code smells. And just use standard refactoring techniques to refactor towards or away different patterns or code cleanliness, I guess. Now, the final part we were looking at was dealing with others. So I drew this box around our system that had this kind of bounded context boundary around the prosecution system. The things inside that box really only make sense to the prosecution department and don't really make a lot of sense to the outside. You have things that are somewhat shared, like cases. Well, the courts understand cases, but their understanding of cases is going to be slightly different than prosecutors. They're going to have different workflows as well. So our idea was that as new agencies came in line that needed to use these systems, was to design something very specifically for them. So one example that came on was the law enforcement officers. The way that prosecutors would receive offenses, how would they find out about someone doing something wrong and getting arrested? Well, a law enforcement officer would actually show up with a stack of, these are all the things I've arrested people for today, and then you need to go figure out what to do with them after this. And so previously, they would physically walk up twice a day, dump a bunch of offense forms, CR23J or whatever it was, on the front desk and go on with their day. So they didn't want to do that anymore. The prosecutors we're tired of dealing with this papers I can't read or anything. So they said, we need something specific just for law enforcement officers for them to be able to submit offenses, arrests, and cases into our system. But we don't want to let them use our system because they have different security, they're dirty, their hands are dirty, we don't touch on their computers. So we're going to build something very specific just for them. So we built a portal for just those folks and had that application designed only for the requirements of that specific agency. And so we'd have these kiosks that when the law enforcement officers would come in, they had a choice. They could wait in the one line that had all the paper-based things, or there were like 6 kiosks over here for digitally entering them in. And the law enforcement officer would see, okay, there's 6 computers over here with no wait, or I got to wait in line over here forever because they're going to make me type everything anyway. So he said, okay, they're going to want to use that portal instead. But that portal was designed just for their needs, just for their user experience. So things like the font was bigger, the buttons were different. They would come in sometimes wearing gloves. We had to design things to make sure they could work with just physically having gloves on. But that was designed specifically just for them. Then we would have an anti-corruption layer between that portal and the rest of the system. So they actually couldn't insert a case into our system. It had to go through an approval process. They couldn't even insert a defendant or an offense or anything like that. That portal had its own database that we would use as an anti-corruption layer. That is, we would take what they wrote in, apply our business rules to it, and then once it's been approved, then that would move into our overall prosecution system. The defense attorneys had something a little bit different. Defense attorneys could be a defense attorney for multiple different counties. So whereas a law enforcement agency typically deals with just one county. So if I'm a cop in Dallas, I never arrest people in Fort Worth. I only arrest people in Dallas. So they only have one portal they're going to. Defense attorneys are a little bit different because they could be a defense attorney for multiple different counties. So someone could be a defense attorney for Fort Worth and for Dallas. And so that one needed something slightly different. We, for that one, built a single portal that could consume APIs from multiple different back-end prosecution agency systems. So for this one, I'm just showing one API, but those portals could actually communicate to multiple different defense APIs. Now that one, instead of us hosting the portal itself, there was a single portal to the side. And over here on the law enforcement, we designed a fully running application by itself. So the portal would communicate to multiple APIs. Those APIs were designed specifically for those portals and nothing else. So we didn't try to have some kind of general purpose like, well, if anyone wants a case information, here's an API that you can go call. No. We built that API only for that one portal and what that portal needed. That meant that we got rid of a lot of complexities around API management, like versioning. Don't have to worry about versioning because I'm not letting this API being used by multiple people. It's only specifically for this one portal. We did have to worry about versioning in terms of the API, the API's model itself, because the portal is consuming multiple APIs, and I don't have any control over when someone deploys that API. We had the possibility, and actually the use case come up, where these prosecution systems that were deployed in each agency could sometimes be deployed years apart. So we did have to make sure that the portal could be able to communicate to APIs that were potentially developed and deployed years apart. We had other ones come in line as well, and each of those had their own bounded context, their own models, their own systems, their own interface exchanges. And as those different systems came online, we would develop integration points that were specific to the needs of those different systems. So initially we thought that we could just do a single API that anyone could use to be able to interact with the system. But as we dug in more to these other constituent systems, we found over and over again that each of those is going to have vastly different needs. So that may even mean like different communication methods. This one's a web application that used an actual REST hypermedia API. The defense one used messaging. And courts, I think, still use some kind of documents because they were still paper-based. So we'd send like PDFs to them, something like that. So that was our fifth big lesson, was that microservices, although they didn't have that name at the time, and any corruption layers are your friend. And once you find yourself having these models that have some inherent friction between them, and you have people that don't agree on basic terms of things, that's a good indicator that perhaps we should keep these two different models apart and have some kind of translation anti-corruption layer between those two models and systems to make sure that these needs and modeling in this system don't leak into anything else. This is hard, though, to do. So if you want to learn about how to draw service boundaries, I highly recommend going to Adam Ralph's talk on finding your service boundaries, where he talks a lot through how you actually go about doing this. For us, because the boundaries have been defined by us already, by the state of Texas legislature, like there will be a prosecution department over here, and these are the forms that you will be using to submit information back and forth. Like, well, just use what's already been defined by the law. But for other businesses, it is a little more complex. So the final tally of this project, we had fewer controllers. We had 70 controllers down from like almost 200 previously. We had more actions, though. This is a much more tailor-made system. Because this was very specifically defined for a single set of users, that meant that we could have a much more task-oriented system, that we model the tasks and actions that the user wants to perform instead of these kind of generic edit pages. So we had a lot more actions the users can do. A lot of granular permissions. We did wind up with 139 entities, which is more than I would have expected. One of the things we do is we ditched value objects. Because we're using SQL Server has, and relational databases have no concept of value objects. And so we also looked at, well, what would happen if we just didn't use those, because those are so hard to model inside the database. And we got to the end and said, well, we didn't use any value objects and nothing was set on fire. Everything seems to be okay. And so for those in the future, I would only ever use value objects in these modeling scenarios if the underlying data store can actually support them. So if I was using something like a document database that does have a concept of values and be able to map that, then I might be able to go with that. And the final result, we had about 30 counties deployed of the system, and it all is also still going today. And one of the great things about this was I went to visit that prosecutor who called original system a piece of crap, and he was just, he absolutely loved the new system. I used to have a video, I couldn't find it anymore, but when we demoed this system for the first time for the prosecutors in the paper-based county, they literally stood up and started applauding because they're so happy they can get rid of all those paper-based files that we're having to like weave around the office for. So while the first system got like mean looks and people yelling at us, the second system, because it was tailor-made for just a specific bounded context, was a much more user-friendly and successful system. So if I had to sum it up, I don't know if everyone's seen this picture. There's this picture came out a while ago that says there's JavaScript, and there's also JavaScript, the good parts, which is like a small fraction of overall JavaScript. And I felt a very similar thing, that if I looked at the domain-driven design book and tried to pull out the good parts of that book, it would be a lot thinner. But it turns out someone actually wrote that book. They just didn't call it domain-driven design. It's actually the Building Microservices book. You go to that book, it actually takes all the good things out of domain-driven design and just distills it down into one single book, but then slaps the label microservices on it because, why not? Maybe like 2 years from now, it'll be like building serverless Bitcoin something or other. But it's all the good parts of the domain-driven design book with none of the fluff of all the things that don't make as much sense. So that was domain-driven design, the good parts. My name is Jimmy. If you want to find this presentation, you can find it on my github.com, Bogard. There's a presentations repository. I'll be sticking around for questions. Otherwise, I hope you have a great rest of the conference. Thank you.